Hey guys, so this video is going to focus on how to write a prime factorization of a number. So essentially when it comes to prime factorization, first off let's start with the word factorization. So the word factor just means a multiplication of something. A prime number is a number that can only be multiplied by itself in 1. For example, the number 2 is a prime number because the only two numbers that you can multiply in order to get 2 would be 1 times 2. 5 would also be a prime number because only 1 times 5 would work, nothing else. 9 would not be a prime number because yes, 1 times 9 is a prime number, but there's also 3 times 3. So if there's another option other than using 1 times that number, then that's a composite number, not a prime. So a prime factorization is when you're able to take a number and write it as a multiplication of only prime numbers. So essentially you want to break that number down and continue to break it down using a multiplication to whereas your factorization in the end only involves prime numbers. So let's start with our first example here. So the first number that we have is the 16. So what I'm going to do is I'm going to build a factor tree, which essentially is just breaking apart a number until I just can't break it apart anymore. So I want you to think and look at the number 16 and think to yourself, well, what times what multiply to get you 16? And there's a few different options. The first option that you pick does not necessarily have to be the first option that someone else has picked. For example, 4 times 4 gets you 16. 2 times 8 gets you 16. So there could be a few different combinations, but really just start with whatever the first combination that pops into your head is. I'm going to go with 4 times 4, just because that's the first thing that I think of when I think of the number 16. And then what you want to do is you want to think to yourself, are either one of these prime numbers? So is 4 a prime number? Right, is there anything that can multiply to get 4 besides 1 and 4? Now 1 times 4 is 4. 2 times 2 is also 4. Therefore 4 is not a prime number, which means that I can break it up again. And I can break 4 up again using 2 times 2. Okay, so since this is a 4 also, we can break it up using it the same way, 2 times 2 as well. So then we need to look at the end of these branches and think to ourselves once again, is that a prime number? So is 2 a prime number? And I mentioned earlier 2 is a prime number. 2 is actually the only even prime number because the only way that you can multiply to get 2 is 1 times 2. There's absolutely no other way that you can multiply to get a 2. So 2 is a prime number. So what I'm going to do is I'm going to circle my 2's because those signify the ends of each one of those branches. I cannot break them down any further. So our prime factorization is what we're going to get when we multiply all these end numbers together. So our prime factorization would look like 2 times 2 times 2 times 2. So all 4 of these end branches all put together, 2 times 2 times 2 times 2 is our prime factorization for the number 16. So even though if you might have started off with a different number, you could have also used 2 times 8, you will always end up with the same prime factorization as long as you keep going till the end. So this is what a prime factorization looks like. So let's look at the number 52 and let's try and follow the same process. So looking at the number 52, let's try and think what times what gives us the number 52. Now I don't know about you, but the first thing that pops into my head is 2 times 26. Alright, so I'm going to start with 2 times 26. And I already know that 2 is a prime number, so I'm going to circle that one. Now is 26 a prime number? Well, 26 actually happens to be 13 times 2. And I'm going to circle 2 because I know that's prime. And then I need to look at the number 13 and think, well, is the number 13 prime? Is there anything else that would multiply us to get 13? I don't know about you, but I can't think of anything else that multiplies to get 13. So that means I am done here. I can now build my prime factorization. And typically we do start with smallest to biggest numbers. So I'm going to start with the 2. I have another 2 over here I can use. And then times the 13. So 2 times 2 times 13 is my prime factorization. So notice every single number that's in my answer is a prime number. If you ever have a number that is not prime, then you know that you are not at your prime factorization yet and you need to keep on going. So let's look at the number 128 and see if we can think of a number that goes into 128. So that one's a little bit bigger, so we might have to do a little bit more thinking here. Now, when I think about the number 128, I think 4 times 32. That's the first thing that pops into my head. And 4 is not a prime number. I know that 4 can be broken down to 2 times 2. And I already know that those are prime. So now that I need to look at the number 32, and if you have any even number that's bigger than a 2, it's definitely not prime. So because 32 is even, I know it can be broken down again, and I believe that 32 can be broken down to 2 times 16. I'm going to circle the 2, but I know 16 can keep going because 16 is 4 times 4. And each one of those 4s is a 2 times a 2. So I have a lot of 2's here. So my prime factorization for this one, well, let's see, is a 2 times a 2 times a 2. And then I have 4 more over here, so 1, 2, 3, 4, to give me a grand total of 7 2's here. 2 times 2 times 2 times 2 times 2 times 2 times 2 is my prime factorization for this particular problem. Moving on to the last one, here I have 17. So we need to think what times what gives us a 17. So looking at the number 17, actually the only way you can get a 17 is a 1 times a 17, and you never want to use the breakup using a 1. So since there's absolutely nothing else that can break down a 17, 17 is already prime. There is no way that you can break up the number 17 using a different multiplication. That one is already prime. 17 is as far as you can go. So this is how you write a prime factorization of a number. That's it for this video.